Good morning, students. Today we are going to see about third unit in VLSI design. The concept name is called pipelining. Pipelining. So, if you want to just take the computation of log a plus b, in general, if you want to take log computation of a plus b, means first you have to do the addition operation, then you have to take the modulus, then you have to take that logarithm. So, these are the parallel pipelining steps in that to compute the log a plus b. So this one you just transform into the diagram. So normally A register and B register have to get, and we are going to give us a ALU. It is going to be do the adder operation. So it is going to be do the adder. Then it is taking the absolute value. This line is nothing but the absolute value. And finally, we are taking the log. That answer is to be stored in the register and it is displayed as an output. So if this case, the first clock period, it will do the addition, second clock period modulus, third will be the log a plus b. So in order to compute one computation, a1 plus b1 with modulus and with log, it will take the 3 clock period. And in the clock period, only one portion will be active at a time. Remaining 2 by 3 portion of the clock period will be the idle. In order to use a clock period efficiently, and we have the two benefit of the pipelining. One will be it will be uses the resource utilization properly. The pipelining concept will be utilize that resource utilization, then functional throughput will be more in the pipelining. And in order to avoid this, we are going to use some buffer in between them. It is nothing but the register. I am placing that register in between the absolute values, here one and here. It is already will be there. So I am going to place two new register where what it happens in the sense once it is going to be add, that value is immediately stored in the register, and this adder is ready for the next operation. So no need to waste for the 2 by 3 ideal portion. So if A1 plus B1 is completed, it is moved to your A1 absolute value. Parallelly, you can do that A2 plus B2 in adder. So previous case adder will be remain ideal for that one. Now because of the register, it will do the further process A2 plus B2. And once it do the completion of the modulus value, it is shifted to the logarithm. Then the absolute value become empty, then it will be loaded with the second computation. Likewise, it will take 3 full complete computation will be carried out in the 5 clock cycle. Thereby your functional throughput will be increases. The next concept is we have the no race module, and we have the two concept. One is called your clock module and another one is called as a clock bar module. So here it will be combination of two things. One will be that combinational logic plus latch. Combinational logic and followed by that latch. Your latch is nothing but C square mass clock, clock or CMOS register. And clock bar also we have the same concept, combination logic plus latch. In that combination logic itself, we have two portion. One will be called as a static portion and another one is called as a dynamic portion. So static and dynamic. And we have the two option for the clock signal. Clock will be denoted as pi and its value will be 0 and 1. If it is the 0, the clock bulk will in the clock block we have the two concept, logic and latch. Logic will be pre-charged mode and latch will be in the hold mode. Hold mode in the sense your device will be going to be off this portion, so it will be maintaining the previous state. So that is called your hold mode. But in the clock bar module, the same for the clock signal input 0, both will be act as the evaluation mode. Meaning it will be every circuit is going to be complete and output will be working according to the input. Output is evaluated the input. That's why it will comes under in the evaluation mode. Both your logic and the latch will be in the evaluate mode, and this concept will be reversed for that pi equal to 1 concept. That is your when clock is 1. Thank you, students.